tour of the CHP plant there, and we're going to spend the next 2 hours discussing heat in the UK. So here we go. So we've got some experts from industry and academia locally here in Manchester to discuss and debate current and future issues surrounding the heat provision in the UK. I'm pleased to welcome IET TV here to capture the knowledge and opinion from the event, so it can be used to create an IET positional paper, which will be given to DEC later on this year. Just as an agenda, I'll begin here with a 10-minute outline of the challenge of reducing our emissions and the scope of this evening's debate. I'll then talk about our 5 topics for the evening. And I must say, if you have questions about the slides, I do encourage audience members to keep them in mind and raise them during the topic when we're talking about them. Time then for our expert panel to take 5 minutes to introduce themselves and the types of projects that they work on. And we're ready then to launch into the questions. So hopefully we'll have 20 minutes per topic, which will push us all the way to 9 o'clock. So the IET, they have responded to over 30 government consultations. You can see the wide range of them there. But we have limited time tonight, so we can't be going into each and every topic here in detail. We have some useful structures which we can adopt. It will help us focus our efforts. The energy supply challenge is described as a trilemma with 3 elements. We've got affordability, security of supply, and our climate change policies, all of which needs to be satisfied in order to supply the heat for the UK. And our energy hierarchy was another structure which describes the way we can prioritise our efforts. So we can see that if we carry on business as usual, we're in an unsustainable state. So we need to move towards low carbon technologies, renewable energy, efficiency and conservation. We'll see in the later slides how we're already making moves to make our housing stock more efficient and conserve energy. So as I said, it's a huge topic and arouses many concerns. Everything from social aspects, technology and resource choices, land use and environment, cost, and tonight we're going to make some 4 assumptions to help narrow down the scope of the debate and produce some good outputs here. So assumption 1 is that of climate change, and that it's generally right, and we're going to accept that we have to do something to meet our climate change targets, which is basically an 80% reduction in CO2 emissions by 2050. Assumption 2 is that we'll have an abundant source of low carbon electricity. Now, whether that's from nuclear, wave energy devices or wind power, we'll assume that that's there and we can use it to supply the part of our heat demand in the UK. Assumption 3 then is biofuels, and we're seeing that there's a lot of other countries out there that will be looking to curb their carbon emissions, so we can only take our fair share. So we can't go importing vast quantities of biofuels to replace fossil fuels. Okay, so and assumption 4, there's going to be equal effort across all sectors. So we can't rely on, say, transport to reduce the carbon emissions by 60% when we do nothing. So DEC have got a useful chart here. It's quite busy, but it really couldn't have been a worse moment than that. Yeah. So we can see here that basically all our primary energy supply is derived from fossil fuels, apart from these narrow, slender flows of electricity from nuclear and renewables and some biofuels, you can see gas here is predominantly used to supply the heat coming out to domestic and other industrial uses. Another point to note here is the efficiencies of our power stations, where we're taking gas, coal and converting it into electricity, and a hell of a lot of waste heat here. And if we can do something to curb these flows, we can cut our emissions quite a lot. If we look at the demand in a bit more detail, taking an annual average here for 2010, we can see that the margins for electricity, we've got quite a low demand here in comparison to the heat demand, which is in the winter time can be 5-6 times the magnitude of the electricity demand. And we can see there that there's no way that we can supply all the heat using our existing electricity system. So looking at one of the sectors in more detail here, we've got domestic energy use, and it's predominantly used, the energy predominantly goes towards space heating and water heating here, and again you can see that it's mostly supplied by gas. So we need to do something about the carbon emissions from the domestic energy sector. So what we are doing is moving more towards low carbon housing, and the more modern homes, together with the energy performance certificates, are simple metrics that consumers can use to choose more energy efficient homes. And hopefully then the developers can start building, and we'll be incorporating more energy efficient homes into the housing stock. But it is a low rate of replacement, and means that most of our houses we're stuck with until at least 2050. And many existing houses are difficult and expensive to insulate. So we look at low carbon technologies, and one of the most proven is of course CHP and district heating, with various fuel sources, and many of the barriers are not technical but rather social. So we're on now to our debate themes for the evening. We've got 5 themes, and around these 5 themes we'll have a question or more. If you want questions from the audience, please do ask questions when we're on the topic. About energy system overview, what would be the ideal energy system to supply the heat? Consumer issues, what would make consumers and customers buy into a district heating system? Future heat provision, what sort of systems would need to be in place, and how can we build and plan for extra capacity in our heating systems? Policy and economics, so what rules and incentives do we need in the marketplace to make it so commercial, industrial scale investments can take place? And number 5 is implementation. So once we get the policy and economics and a proper consumer or commercial environment in place, what will it take to implement these technologies and to supply consumers? So without further ado, we'll have a short introduction. We've got 2 Franks here tonight, and we've got 2 Chris's. So you've already met Frank Welsh, who gave you the tour there, and he's head of operations here at PLG Utilities in Manchester. We've Chris Marsland here from Ener-G in Manchester, and they're a CHP manufacturer around the corner here in Salford. We've Chris Jonas, who's head of strategic development for Viridor in Somerset, and we've got Frank Welsh, who's low carbon consultants, Liverpool. So I'll ask Frank to give us 5 minutes introducing himself and the type of work he does here.
Hi, good evening. I'm Frank Welsh, Head of Operations for PLG Utilities. Although, like I say, I chatted to a number of you in the Energy Centre just now and explained what we do on a day-to-day, week-to-week basis. We basically operate a number of licensed and private systems out in Great Britain. We basically have a licensed water and wastewater business that operates here at Media City, Peel Water Networks Limited. That's the first inset appointee in the northwest of England. So we kind of broke the back of the Ofwat arrangement over in the northwest, and obviously United Utilities kind of domination as such in this patch. We also have a number of private systems here at Media City. So we have a private electricity system, as I explained to you before, that we take a supply from Energetics to site, and then we transport it HV and LV to a number of the buildings. And also, obviously, the key facility on site, which is the Centralised Energy Centre facility, which we class as a Trigen facility, provides electricity, heating and hot water and chill water facilities to a number of the buildings on site. We also have a site down in Liverpool, which is in Speak, Liverpool Business Park, where we take a 33 kV meter supply from Manweb, and we transport power and supply power to high voltage and low voltage customers on that site. We also have water and wastewater services at that site as well as a private arrangement. Over at Robin Hood Airport in Doncaster, Sheffield, we basically provide water, wastewater and electricity facilities there as well. So again, we have a private system for water and wastewater and a private system for electricity. At the Trafford Centre, we provide water and wastewater facilities. Down at Mersey Docks, we also provide water facilities, and from Manweb's 33 kV system, a private wire facility to mixed use, again transporting at HV and LV. Basically our operations arm basically does everything from operate, maintain at the front end, all the way through to credit control and debt collection at the back end. So we construct commercial deals with each of the customers on our sites. We actually provide the contracts as well, so all the contracts are in place for all of our services. We also undertake the billing through a bespoke billing system that we have, and then we have a credit control facility as well, so we chase up all the outstanding payments and make sure that what we charge out we recover for our credit control. So in essence, it's like running a number of businesses across a range of services through a team that I manage, covering customer services and field services operations. Peel Utilities also have a number of other arms. We have a company that runs abstraction and discharge facilities up and down the country. So again, water courses that belong to Peel, like the Manchester Ship Canal, the Bridgewater Canal, the Medway, Mersey Docks, Clyde-Port. We contract and strike commercial deals with customers for using those facilities, for abstracting from those water courses, for the requirements of processes and for discharging back into those water courses. We also have a business development arm. My colleague Adam Giblin's here tonight, business development manager, looking at, again, all aspects of water, wastewater, electricity, district heating, looking at new opportunities. So again, regulated, private, making sure that we're taking advantage of competitive markets that are out there, facilitated by Ofwat, Ofgem, again, incentives that are out there for heat, for power. So again, looking at solar opportunities, like I say, opportunities like the district heating system we've got here at the Media City site. We're replicating that at other sites where we will be adopting assets at in future. So we have a number of developments in the Peel portfolio that are looking to take place now over the coming years. So your Liverpool Waters, your Wirral Waters, Chatham Docks, etc., etc. So again, you know, we're involved, like I say, within the Peel Group to look at bringing those opportunities to fruition within Peel Utilities, adopt those assets, and then obviously run them through the part of the department that I operate. So that's basically the Peel Utilities business in a quick run through.
Hi, good evening. My name is Frank Mills. I'm a consulting engineer, and I was consulting engineer to Peel on this particular project and designed the district energy scheme which we're going to be discussing, which we've just seen. My background is that I'm a building services engineer, or a mechanical and electrical engineer, that really looks at how energy is used within buildings and what kind of systems we put into those buildings in order to make them operate. But sometimes we go out of the buildings, as we've done here, and look at how we might supply energy to those buildings more efficiently. And really what happened here is we came onto the scene a little bit late, or I came onto the scene a little bit late. The site had already started, there were foundations going in, and the design teams working for Peels were putting in what we call business as usual. Gas supplies into boilers, electrical supplies into chillers, water supplies into the buildings. And we said to Peel, well look, if you own all these buildings, why don't you have an energy centre and supply them all from one point? Because it's much more efficient and cost effective. And Peel are a client who I would say have an interest in long-term investment. They're not out to make a fast buck, they're out to make a profit, but they really look at how things work in the long term. They're also interested in how they can provide a better service to clients. So if clients can get energy cheaper or easier, this is advantageous because it's appealing to tenants and others coming in. And one of the big tenants here is the BBC, of course. So Peel began to listen to what I had said and came up with a scheme which is based on the energy centre you saw, heating pipes that distribute round and connecting to every building, so that heat is being purchased by those people at a lower cost than they would pay if they were paying for gas. And they're also getting the advantage of cooling from the canal, which is a low-cost cooling in winter, and through the absorption cooler in summer. We took it one step further with Peel and said, well, look, if you really own the whole site and all the buildings on it, and you're interested in BREEAM as an environmental rating, why don't you look at rating the whole site with a BREEAM scheme called BREEAM Communities? Now, at that time, I'm talking 2006, that didn't exist, but the BRE, who own the BREEAM rating system, were interested in looking at whole sites rather than just particular buildings. So we introduced Peel to the BRE. They both decided to work together to pilot this new scheme, and this site ended up reaching an excellent rating. So it's the first scheme in the UK to get an excellent rating for BREEAM Communities. And what that really looked at was all aspects of sustainability on this particular site, energy certainly being one of them, but air quality, water, health and safety, placemaking, communities, social inclusion, all the issues that make a place really sustainable. So we were pleased to do that. Moving forward, I've kept in contact with Peel and continue working for them. So on their new schemes, Wirral Waters, Liverpool Waters, Trafford Quays developments, and Glasgow Harbour, there's a number of schemes around. Peel start by looking at sustainability on the whole, and they start by looking at an energy strategy based on a distribution system, and work with people like Adam and Frank here on how that might work from a business point of view, so that the tenants, those moving on to the scheme, benefit, and Peel are also able to expand that business, create local jobs, and provide cheaper, more efficient energy schemes. I think beyond that, just briefly to say, I'm also I'm a member of the Chartered Institute of Building Service Engineers and chairman of the Preston Centre. I'm a member of the Construction Division of the Institute of Mechanical Engineers and a member of ASHRAE, which is the American Society of Engineers, and active in all those organisations in promoting energy efficiency, district energy and those kind of things. Thank you.
Thanks, Frank. Good evening, everyone. I'm Chris Marsland, Technical Director of Ener-G. We're based in Salford, just a 10-minute walk that way down the road. Ener-G make their business from providing low-carbon, low-energy solutions to their customers. We've been in that business for 30 years now. We started as a technology spin-off company from UMIST. In actual fact, we've still got one of the original members of staff with us. Our original business was based on combined heat and power, and it's still very much central to what we do. Gas-fired CHP, be that natural gas, be it biogas, be it any sorts of weird and wonderful gas, if we can get it to burn in an engine, we will do it. The business has changed recently, maybe in the last 6 to 7 years, and instead of providing just a CHP to a customer, we will now deliver a broader set of solutions, an energy saving, energy services sort of solution. So we'll enter into a contract with a customer to guarantee providing them a fixed energy cost over a period of the contract, or reduce carbon emissions over the period of the contract. And we do this by adopting a basket of technologies now, whereas previously it would just be we put a CHP in. We're now embracing the sort of low energy LED lighting. We're putting solar PV on roofs of buildings. And believe it or not, we're still going into buildings, into boiler houses, and finding completely uninsulated pipework, uninsulated plate heat exchangers. So, there are still some simple wins to be had out there. It's not all about throwing technology at these things. So that's our approach to the market. We will sign up for 5, 10, 15-year contracts with customers. These customers can vary from local councils, sports centres, the David Lloyd chain of sports centres is a good example, through to, and I've got to say it because I'd be shot by our marketing department if I didn't, through to the Royal Household. We've got units in Windsor Castle and Buckingham Palace, and then through to the industrial side of things, so we talk about biofarm, that type of thing. Our sort of take, if you will, on this whole topic tonight is very much focused around district heating and the part that CHP can play in that district heating approach, and that will be, I guess I have to say that now, some of my answers will be tainted that way, so yeah, thank you.
Thank you, Chris. My name is Chris Jonas, Head of Strategic Development at Viridor. Viridor is a recycling, waste disposal and renewable energy company. We are our primary functions at the moment is to take household waste and recycle whatever we can from it, but we're moving more and more into the elements that we can't recycle into the combustion of that material in an energy from waste plant and doing something primarily generating electricity, but in some cases generating heat from the output of those plants. We've currently got 11 plants identified at the moment. We've got 7 of those in construction, 2 of those waiting to commence construction, and 2 of them further afield. So we have a hugely active capital expenditure programme on the way now. We've got a small plant in Exeter. We'll start operating next week. Next month there's a very large plant, largest in the UK. We'll start operating it at Runcorn. And 2 other plants further on this year will come into operation. And our interest in this area is primarily in district heating and in CHP is to find for the right plants in the right locations, either industrial or commercial uses to use heat output from our steam turbines. All our turbines are primarily electrical led. They're electrical power stations. But there is plenty of scope and opportunity for using some of the low pressure steam in terms of the heat. Our project in Runcorn is going to use half the energy into the Ineos claw factory and half that energy is going out by steam. We've got another plant near on a junction of the M25 and the M4. We're pretty close to announcing a deal to get a substantial amount of 6 megawatts of heat off that plant. We have a plant in Cardiff at the moment. We are one of my main bits of work at the moment is to try and herd all the sheep around Cardiff to put into place a district heating system 12 kilometres long around Cardiff city centre, primarily driven with the generation from our plant. So, and a very important part of the world this is to us here in Manchester, where we're contracted by the group of Greater Manchester authorities to manage the recyclables and the waste disposal functions for all the authorities in Manchester here, and we have a number of 4 anaerobic digestion plants in Manchester, 5 mechanical treatment plants, dealing with all the household waste in this area. Okay, thank you, John.
Thank you, Chris. So, thanks for the great introduction there, guys, and we'll start into the first of our 5 topics. So, as I said, with an energy system overview, and what are the characteristics of an effective energy system structure, and particularly with regard to urban heat, how do we derive such a system? Now, what I was going to do is have 1 question to the panel, 1 question then to the floor, another to the panel, and 1 more to the floor. So, how would you like to start us off, Frank? Yeah.
I think really in terms of an effective heat network, something that's going to be viable and cost effective, you're looking for a fairly good mixture of use so that the heat network requires heat, all year round. If you have a heat network that only requires heat sporadically or is very peaky, then it's really going to put great loads back on your main plant. Also, the kind of plants we saw down there, the combined heat and power plants, they don't like to switch on and off or even turn up and down. They like to run flat out. So we're looking for nice steady loads. Of course, when we go out into the real world, into buildings, and I'm a building service engineer, heating comes on when we start in the morning, goes off when we go home at night. If we talk about our house, we turn heating on before we go to work. We maybe switch it off when we go to work, and we want it back on in the evening till midnight. So we can see that the actual loads we're dealing with are quite spiky time-wise, and then we've got climate on top of that. So in the middle of the winter now, we probably want quite a lot of heat. Come April, May, June this year, we'll be switching our heating off completely, so we won't want any heat through the summer. We also find as we're going into new building types that the actual heat demand can be very low. So the whole of Media City here is a pretty brand new complex, and the heating demand of the apartments and buildings here is much lower than you might expect because they're super insulated buildings, they're modern buildings. If we won't go down the road to terraced housing in Salford, we find they're pretty poorly insulated. Even if they're insulated, they're not as well insulated as these buildings, so they do want heat. So really, in a nutshell, we want a nice steady load, and how do we get that? So I have one story to relate to is we were looking at the Wirral Water Scheme with Peel, and their director, Richard Maudsley, was there, and we were looking at how we would get a heat strategy that would work. And I must have been looking quite stressed because he said to me, well, what are you worried about? You're looking worried. And I said, well, we're looking at the buildings that we're going to put on this development, and I see a very spiky heat demand, and I think, and he said, well, what do we do about it? And I said, well, why don't we have some people who want heat in the summer? We need some hotels would be good, and perhaps some restaurants, a leisure centre, swimming pools, they always want heat. And what about a data centre? Because we could put the heat into a distribution absorption chiller and then provide cooling to a data centre. And I looked around, he's writing this down. So I said, well, what are you doing? You're writing. He said, well, I'm going to go back to our marketing people and say these are the kind of tenants we want in, besides all the other commercial uses. And I kind of thought, well, here's me, a simple engineer, saying who should be in this development. And I thought, well, maybe this is something we have to think about as we move forward. Maybe we've grown up too used to getting energy off a gas main or electrical supply into a building, no matter what we do with it. Maybe we've got to think again. As we move forward, our developments need to have a better mixture of users so that our heat and energy supplies are, in fact, flatter and more friendly, if you like, to the distribution. The other thing we can do to try and flatten those out, because we will never get them completely flat, is think about thermal storage a bit more. We're not very good in this country at thermal storage, but I've seen systems in Germany and in Italy where they have 6 months thermal storage. When they have that heat in the summer they don't want, instead of chucking it like we do, they put it in a thermal store so it's ready for the winter. Okay, maybe that's a bit expensive and a bit extravagant, but how valuable is heat? How valuable is it today, and how valuable will it be in 2000 or 100 years' time? We need to think more carefully about energy and put the systems in place so that the way we use energy is more suited to the way we manufacture it.
Thanks. I think I'd certainly like to agree with Frank on the idea of thermal stores. I think that's a massive point that we miss. I think other countries do it a lot better. I think you need to go to the likes of Malmo and some of the Danish countries where they have these district heating schemes with thermal stores, and it's not just the case of pumping in heat from a CHP or pumping in heat from a boiler. They can actually use that the whole thermal capacity to store energy. So you've got wind farms that are producing off-peak electricity because the wind doesn't always blow when you want the electricity. So they use resistive heating to heat the water, and then they can actually effectively store that energy. Equally, solar thermal goes in there as well. So I think that there's a big part to play for really understanding the thermal store aspect, and we see it more nowadays. We're seeing customers specifying thermal stores in what they require. But they tend to specify a thermal store, and it's sort of probably 10,000 litres, and that will last, I don't know, an hour, maybe something like that. It won't last very long on most of the buildings. There's a perception of how big this thermal store needs to be we have to overcome as well. I think to get back onto maybe the specific question, one of the problems that I think clearly a problem we see at the moment is the idea of these big energy suppliers, and they've clearly fallen out of favour with us as the customers. And I think we need to be careful as we move forward to maybe a district heating sort of energy network, that doesn't follow with it, and that we learn our lessons from what's happened with the big six and the way they distribute or the way they charge their energy, and that there's proper regulation and proper customer protection in place to make sure that they don't end up as sort of a similar problem. Equally, I believe that there's a lot of talk about massive, great big sort of citywide networks. I think that's possibly a mistake. I think we should start to drive the adoption of district heating schemes and urban heating schemes through much smaller district networks based on maybe new developments or based on smaller communities. And then as we get acceptance from that, then we should drive through and from there start to link those schemes together and then create the big network. Let's not go for the big bang all at once. Let's sort of bring this technology into people's understanding. And I think that is a key point as well. It's about education. It's about trying to convince people that a district heating system is not, and maybe this is partly sort of I'm bringing this to it, but even now when people say district heating systems, there's still that little thing at the back of my mind that's got a picture coming up of a Soviet era sort of grey tower block with lots of pipes and steam hissing out of it that is either too hot or too cold. And we've moved so much further on from there, and people need to understand that. Just one of the final point is that it's also, and forgive the use of the term Englishman, but it fits, is that an Englishman still thinks of his home as his castle. And he wants the independence. He wants a boiler there. He doesn't want to rely on someone else. And it's all, so much of it is a mindset and a customer education thing. It's not about technology. Yes, maybe it's quite a bit about finance, but it's not necessarily about technology. It's about customer education, customer acceptance, and customer understanding. And just to end that little bit about, there's a district heating scheme that we're very familiar with down in London. And had a very interesting conversation with the guy that runs it the other day. He was telling me that he'd driven past one of the blocks of flats and seen the gas company there installing a gas boiler in this person's house, in this person's flat, because he didn't like the idea of being connected to the heating system, and he thought it would be cheaper to have a gas boiler running in his flat. So it's actually about education and about explaining to people the benefits. We can do it, and I'm sure we can pay for it. We just need to get people to accept it as the way they should go. Thanks.
Yes, I fully agree that education will take us an awful long way of what people in terms of this journey. But I think it's also going to need leadership from local authorities and from planning authorities. I'm pleased to just this week in Cardiff, a new development of an old brownfield area of Cardiff called the Dumballs Road area has now been given an outline planning permission, and the developers put forward a system that all the residential properties, 2,000 properties, and all the commercial properties in there, none of them will have their own boiler system. They will all be connected to a wet system, and there won't be any gas mains in and around the complex. It will all come through a centralised energy centre, like what we saw downstairs today. So hopefully that scheme will take off, and hopefully. But that is leadership. That's leadership from the planning authority, from the director of planning, and with the working with the developers, saying that's how we want to take this area forward. So, whilst the old buildings, the poorly insulated buildings, the cathedrals, the museums is the low-hanging fruit, they are perhaps. But you do need a modern new development to kick off something in a certain areas like that.
Yeah, I mean, listening to what the three guys have said there, I concur with everything each of them have said. I think all I'll add is that, to be quite honest, like you say, the key principles of low carbon and sustainable environments need to be taken account of in terms of how we build systems, what systems we design, spec out in the first place. I think what the key is really to understand, like Frank mentioned earlier, is the kind of the apparatus on the primary system, so the equipment actually being twinned with what the receptors take, so matching basically the heat demands, the electricity demands, so you have got really, like you say, a supply and demand environment that's fully in tune. That to me is a low carbon environment, and what we really should be looking at is displacement of kind of historical incumbent systems to a certain extent if you're going to facilitate a local environment. So again, looking at electricity generated from a CHP plant like we have in the Energy Centre, heat generated from a CHP plant, boilers there to top up and stand by. Again, that provides a base load for the site that meets the electricity and the heat demands of the site, and also the cooling demands as well, because we've got an absorption chiller that uses that heat in the summer months that isn't used in the DH mains for heating and hot water as such. We can use a coolant facility on site and then top up from the grid in effect. So top up from the grid for gas and for power. So in effect, you're using the grid as your crutch, you're using it as a top-up facility. It's always going to be there because there is going to be the requirement for resilience and for standby arrangements. But as I say, it's a local supply for a local demand.
Okay. Thanks, guys. Our second question on the theme of consumers. What would encourage customers to buy into district heating, CHP and low carbon heat? Now, we heard from our panel here that customer independence was quite high up there on what customers want, to have their own heating system and their own control. But what do people feel is the most important aspect of their heating systems? And what would encourage you to buy into a district heating system? Up the front here. So if you could just name yourself and your affiliation before you...
Howard Redding, largely retired. I think a lot of the problem with people not wanting to be dependent on things like central heating, combined heat and power, probably goes back to the crash of 2008, because we've all learned to distrust large organisations. We don't trust our banks anymore. They've sold us, they've behaved unethically, they've gamed the system, and it's come back to bite them in the backside. We don't actually believe our energy suppliers anymore as a consequence. Part of the Thatcherite policies are coming home to roost because nobody's invested in a steady supply of new power stations. So we're very reluctant to say, I'll put all my hot water and central heating in somebody else's hands. That's one area. The other area, picking up on what the panel said, was that if we start with small schemes and then interconnect them, there's an implication there. And the implication is that we have standards that allow everybody to interconnect. It's a little like some of the original electricity distribution systems set up by corporations. Everybody had their own ideas, there was no standard voltage. In fact, some of them ran at different frequencies and that sort of thing. So if you want to start with a small system which can then be interconnected, what it implies is that we set standards now. But the problem, of course, with standards is as the thing moves on, you can actually be embedded on a standard that is no longer relevant, so that's another area.
Okay. Yeah.
Just to agree with everything you just said, and I think this switched on. It is a point to bear in mind that the heat networks are unregulated. So Ofgem regulates electricity, water, gas. If you're on a heat network, there is no formal regulation, so you've got to be very careful. Certainly in all the schemes I'm dealing with, I'm talking about community ownership, in this case a developer ownership of the scheme, so they've got a very real interest in the people on it. I'm dealing with some of the big six on the schemes, and they're quite negative at the moment. I mean, the big six energy companies could come and do this tomorrow. They've got the money, the wherewithal to go and do district heat. I just don't see it happening. I don't know what the problem is, but they've not got the will, if you know what I mean. But you're very wise to raise that point of long-term commitment. Certainly, none of us know what the energy market is going to be like in 5 or 10 years' time. We need to be sure that whatever we've got can be future-proofed. If gas runs out, if fracking doesn't work, if nuclear becomes big or whatever, we've got to be able to get that heat in through our network, through whatever means. So we're not really locked into any one particular supplier. So whatever the arrangement is, whether it's community ownership or whatever, we're able to adapt our change in the future.
Yeah, I agree. I think it's important we do need standards, and I think that was something I would have brought up on one of the later slides. There is work going on within the industry, both on technical standards, although that's nowhere near as advanced, but very much on the customer protection, consumer protection side of things. There's a voluntary code being worked up by various bodies at the moment, which hopefully will go some way to dealing with the issues you raise, and it's very valid issues because, as Frank says, there isn't an ombudsman or there isn't a regulator that you can complain to, or that will make sure that there isn't an unscrupulous supplier out there. So yeah, no, I do agree, but I still think we should aim for it.
Yes, I mean, certainly we should be aiming for that as well, but I think we also perhaps need to be considering, I mean, many of the most successful schemes in Europe are actually run by the municipalities, by the local authorities. That is how what happens in there. I appreciate some of the images we have of perhaps some of the more Eastern Bloc countries where people have got taps in the radiators and taking the hot water out. They're one-way systems. There is no flow and return. We don't want to be in those types of systems, but we do. But leadership by the local authorities, whereby many local authorities have got to be looking at different types of funding models forward into the next generation, and perhaps by investing in some of this infrastructure now to enable them to provide energy supply arrangements in the form of this heating can provide them some form of income into the future, which they can regulate for their local communities. That's separate from that into the future is possibly a model to look at going forward.
Can I just make one other comment? I mean, to throw that question back, how much do we trust the big energy companies to keep providing energy? Are they investing, and are they able to keep providing gas and electricity? And I say that I went to a very inspirational talk by Tim Smith, who owns the Eden Centre, and he was trying to persuade the people of St Austell in Cornwall to get together, club together, and basically set up their own energy company because he doesn't trust these guys in the future.
Yeah, I'd just like to make a couple of points. I mean, I've seen information recently from the UK District Energy Association, which Peel Utilities are an active member of. Consultations are out there in the marketplace at the moment. I believe a current one has got a mid-February deadline to do with metering and billing. So at the end of the day, DEC are actively involved in these for us. DEC are putting consultations out there for responses, for digest, for obviously feedback. Peel Utilities ourselves, obviously, as you've seen today, we run a centralised energy centre facility here at Media City. We do have receptors, as I said before, the organisation that I operate basically provide an end-to-end service. What we do in terms of charging customers is we do benchmark to tariffs that they would ordinarily get out there in the licensed world for electricity and for gas supplies. So they are no worse off, and in certain instances, again, what we do is we offer facilities that suppliers would offer, such as discounts for direct debit payments, etc., etc. So we are in line with what takes place out in the licensed world. I'm sure other parties who run district heating schemes such as this are obviously applying those standard best practices as well. So I can understand customers being a little bit apprehensive, but I can assure you parties who are actually running these schemes are running them in line with, like you say, good practice, and obviously consultations are out there in the marketplace to start to move to more standard centralised arrangements.
Well, that applies whilst you're small and you're having to compete against the big boys. I think one of the fears comes when you start to merge and become larger, and then you become a big boy yourself, and at that point trust can be lost, and gaming can start up, because we've seen so many organisations game the system. On the question of do you trust the big six, I mean, I think it was John Arnott, the Olympics Delivery Authority, said he thinks the best thing that could happen in Britain would be for there to be a few blackouts, because it would concentrate a few minds. And that's because basically about 30 years ago we had free market economics can do no wrong. Well, run that past me again about the banks. And it's now starting to happen in the electricity supply industry, because so many regional electricity companies have done a lot of asset stripping and cut down on long-term training. I mean, United Utilities basically asset stripped Norweb and then spat the bits out to the bankers who overpaid just before the crash. Anyway.
I think the key is, your comments are extremely valid, and obviously we take them on board. As I say, I think, you know, just as the district heating requirements in Great Britain is starting to kind of, you know, take on a bit of a pace now, consultations are out there in the marketplace. They are coming into, like you say, the governing organisations like DEC and UKDA at the right time. Parties like ourselves, and I'm sure other parties like these guys at the side of me, will obviously take an active look at those consultations and respond accordingly to make sure that the well-being of customers is certainly a priority up there, as well as making sure that the right assets are constructed for the right heat off-takes. I think, you know, that is absolutely fundamental to a successful facility.
Thanks, Frank. We have another question there.
It was a comment, Chris Jones, University of Manchester. It was just to highlight, did some research a year and a half ago now on domestic heat user perception of district heating. And there were two findings I thought I'd raise in case they're of interest. First picked up to the point about the role of local authorities and the issues around trust and supplier, particularly on the long term. I know people don't actually switch their energy user particularly frequently, but I think there's the physical sense of being locked into district heating is something that I think is important to consider. But having trust in the organisation that's providing that and some kind of recourse against the potential for exploitation is a key thing, but it's not something that's intractable. I think that is something that came out of those group discussions. And the second thing I think is interesting as well is comparing district heating to other alternatives that include heat pumps, was that district heating systems that mimic to whatever extent possible combination gas boilers, which people are comfortable with, have competencies and feel sort of know how to build their household routine around. Was a big advantage as potential if the heat exchange unit can operate in the same way as a combi boiler from the user's perspective, can occupy the same internal house space, i.e. doesn't require any more people to lose any more of their internal or external space, and they don't need to learn any new skills in order to operate it. And those came up as potential advantages for selling district heating to domestic users. I think that's the key segment of the market which is missing when you talk about district heating, because commercial users and industrial users are obviously easier in some ways to network, but it's the existing heat users that are the biggest part of the market and the hardest to get. But I think with a better understanding of what they think about energy, there's definitely an opportunity to expand into that area.
We've got a question down the back there, Martin. Lady at the back.
Hi, my name's Claire Marie Boggiano. Background is engineering and I work in change management, and I just wanted to go back to the question actually, what would encourage consumers or customers to buy into this? And you're really looking at a change in consumer behaviour, and as a consumer of heat in my house, you know, I'm taking myself as a case study. All you need to do is convince me it'll be warm, it'll be cheaper than it is now, it'll be easy to use, and it'll stop my husband turning off the heat. And I can have as much of it as I want. Now, that's sort of easy, the answer, but obviously there's loads and loads of implementation challenges along the way. I do think if you look at cooperative models or group buy-in, or, you know, helping people to buy into a big concept for a personal benefit, but the reward is a sort of a longer term financial reward, but also you're just warm. I have been freezing since November, so you know, if you can just be warm whenever you need to be, that it's worth it and it's worth paying for. So, but looking at how you have that pull as well as that push, so yes, you can challenge it technologically, how do you do it, and financially. I think you'll have a lot of consumers, people particularly have their own houses, who are just getting absolutely nailed financially on heating and electricity bills, that are seriously looking for an alternative and don't even know it's possible technically. And you just have to demonstrate it, and then they will be biting your hands off if you can do it.
Yes, good point. No? Anybody in it to add to that? Or? Right.
I think it's a very, very good point there, and I think you're right, there's a lot of advantages. I think the other big advantage is that you really don't need a gas supply. You might still keep a gas supply for cooking, but you don't really need a gas boiler. So all those worries about servicing the boiler, having it checked every year, which costs you money, getting a gas man in, all that goes. If you have a problem with the heating system, you pick up the phone, it's somewhere else, somebody else sorts it out, it's not your issue. If your boiler goes down at home, and mine usually goes the week before Christmas, got a big panic trying to find out how to get spare parts for it, or get another boiler in, you know, that just goes. Somebody else is providing you with heat, you kept warm, and if you see a heat sensor like we've seen today, there's bags of backup. It's maintained by a proper industrial company, not the local plumber. So there's a lot more reliability, no worries about gas. Take the gas out completely if you like, and just save the standing charge and just rely on electric cooking. So there's lots of advantage, I think, that way round to customers.
Thank you. I think we have another question down here.
Just your name and affiliation.
John Tarby, I'm a member of the IET. The question I've got, to some extent, goes back to the first question we're looking at. But the CHP schemes we've seen here, with the exception of the waste incinerators, are basically about being more efficient ways of using fossil fuels. If we're looking at the long-term, very low carbon, sort of post-fossil fuel era, what proportion of our overall heating could be provided by CHP and district heating? And given the assumptions that were presented at the start of the debate, that some effectively low carbon source of electricity will be found, will the super efficient, super insulated modern houses of the future want CHP, or will electricity be a more effective and efficient way of meeting their heating needs?
Yeah, I think that's a really interesting question, because absolutely in very modern, efficient houses, solely thermally very efficient, there is absolutely an interesting question about how much heat do you really need for those houses. But we will still have an aging old housing stock that will not have the insulation, that cannot physically fit the installation, or the installation is not still there, or they're big space heaters in industrial premises or whatever. There is still going to be a need for a low carbon heat supply into buildings that can't be as thermally as heat efficient as modern buildings. So then that is the low hanging fruit. That is, I believe, where we should be targeting most of the efforts where possible. But maybe the way to get there is through this pockets of new development which can create the infrastructure because putting the pipes into the ground is the most expensive thing about this whole process. £1.5 million a kilometre to put in there, to put the pipes into the ground. It is the most expensive part of the process. Once the pipes are in, it's relatively straightforward. But we had our gas pipes put in tens of years ago, our water pipes in many older than that. That is the challenge facing us, is getting the distribution network into place.
Yeah, I think at risk of getting slightly distracted from the question, though, I do agree there is, whilst we've got gas now, we will have gas acknowledged at least till 2050. We do need to think, we can't just have our mind set on gas will be good. We do need to look at the options of hydrogen fuel and those sort of approaches. But to pick up Chris's point, there is a massive role for the local authorities to lead on this and to put those networks in, because like Claire said, she can have that heat, but it can't be. The network has to be in place first, so someone has to take that financial and business risk, and you're going to struggle to get a private finance person or private company to take that on. It has to be led by the local authorities. Now, they've got lots of issues to do with not understanding the technology, not understanding the contracts, not understanding a lot of things about it. And I think one thing that DEC has done, which has been very worthwhile, is they've set up the Hindu, the Heat Network Development Unit, and given it £6.9 million of money to help local authorities understand what they have to do and how to do it. The money's not there to fund it, but the money is there to get them over that hurdle of how to get the ball rolling and how to design it. So I said I got distracted from the question, but I just want to get that in. Sorry.
Thanks. I think looking at new housing, as you say, is getting more efficient. So with an existing old house, the heating energy consumption might be 80%, the hot water 20%. In a new modern house, the heating energy consumption over a year is probably only 20-25%, and the hot water demand is 75, maybe 80%. So we kind of reverse those figures. But the fact is, they still need heat for hot water and a bit of heat for heating. So we've still got to get heat out there. I think the point Chris made is valid, is there's a big investment in the distribution network. And those kind of pipes we saw down there have a life in use in the ground of about 50 years. So it's a big long-term investment. The bit of kit on the end, and Chris might know more about this, but it's got a life of around 14 or 15 years. So that CHP engine, which is banging away, it's doing a great job. It has to be renewed in 14 years' time. At that point in time, we might say, well, you know, gas isn't the great fuel anymore. We need to do something different. You know, biomass, heat pumps, maybe nuclear energy has come to the fore. We're talking 14 years away, and nuclear energy is really cheap, so we put an electrode boiler in. But the fact is, our big investment in the pipe, as Chris said, that's the one that's really going to safeguard us to keep people nice and warm, whatever fuel source we have in the future.
Again, I concur with all three of what the guys have just said there in terms of those provisions and those offtakes. I think the key as well is basically to flip your answer on its head down there, sir, and just think about, like I said previously, about displacement. I mean, to be honest, the legacy systems that have been put there that we've used for years, gas, electricity, etc., you know, like we've got at Media City now, we've got a three-part system there. We've got a system that provides power and heat from a plant, so you're getting two products out of that, plus we've also got a coolant facility for heat that may not be used in the DH mains in the summer months, can be used by an absorption chiller to provide chilled water. So in essence, you've got three facilities coming from that one facility in essence, whereas historically you would have probably had a couple of facilities. You'd have had chilled water coming from an electric-based system, and you would have had heat historically coming from a gas-based system. So I think it really is looking at really what you're getting for your buck. And if you're putting a CHP plant in, you're getting basically free services from that particular appliance. Now, yes, at the moment, you're quite right, fossil fuel is sourcing that appliance. But in future, we can look at biofuels, we can look at biomass, we can look at other technologies that, to be quite honest, will be a low-carbon fuel, but still provide those three outputs that will be low-carbon. So, again, you're quite right, it is looking after the customer's interests, but I think, to be quite honest, that is looking after the customer's interest. It's giving you a lot more facility from a centralised service.
Okay, I think we've time for just one more down here.
Hi, my name's Aziz Bakati. I'm an electrical engineer. I think you've brought me in. I quite like the sound of the centralised system. Part of my question's been answered, but I'd like to say it anyway. As long as the customer believes he's making a saving and he's got a reliable supply, I think you're going to win him over. The thing that I can't see happening straight away is having this on existing homes. You can see it on news sites like here. You have the old area that was clear, and you could have run pipes, etc. But how would this work, running it into people's homes? Is my question.
Anybody like to take that one? Chris?
It's a good question, and I think that's really the big challenge for us. As you know, in my business, I'm a building service engineer. It's my job to keep people warm in the future. I did a study for the Eldonian group in North Liverpool. They're a social landlord group backed up by the City Council. We were looking at how a district energy scheme could, solve their problems and help regenerate North Liverpool. And they saw it in all sorts of contexts. I mean, the first one really was fuel poverty, keeping people warm using this waste heat, and at the same time creating jobs. In order to get this stuff in, we've got to employ people who know how to put pipes in the ground, connect them up into housing, meter them, as people do, charge them. So there's a lot of kind of manpower required in a city which has a lot of unemployment. So putting two and two together there, we went for a bid for Europe and got money in to support that in terms of job development. Some people say, well, where's all the money going to come from that's going to pay for that? All the pipes in the ground, distributing heat from an energy centre. Well, quite simply, the heat that we're selling is waste heat. At this point in time, that heat is being thrown away by a power station in Britain somewhere, Fiddler's Ferry. We're chucking it away right now. So the heat that we're going to sell to those people is being paid for by the money that we're not going to give to Russia. We're giving Russia and other countries money to buy gas, oil. We put it into a power station, make electricity, and then we throw about 2/3 of that energy up the chimney as heat. So if we convert that waste into distributed heat, which is free, and then change the money from the supply over to a foreign country and keep it in country, we create jobs. As you say, the real issue is how we get down that road and connect into every housing. It has been done in some parts of Britain. Nottingham, Sheffield have district energy schemes. If you go to Malmo, 90% of the city, including housing, is connected. So the technology's there. What we don't have in this country is the manpower, the skills, and the willpower to make it happen. But if we do go there, we save this country a lot of money, and we create a lot of jobs, make a lot of people wealthy at a working level, and we keep people warm.
Thanks very much. Great questions there. And time-wise, we're going to have to push on to number 3. And this is about future heat provision. I've got 4 questions up here I'm going to ask. The first question here to Frank Welsh. What are the future opportunities to use heat from major power stations, and how could associated challenges be addressed?
What are the future opportunities to use heat from major power stations? I think similar to what Frank said there previously. I think if you take test cases out there in the marketplace at the moment, so for example your Fiddler's Ferries and power stations of that ilk, I think like Frank just mentioned, you know, a lot of the moment is all about power production and heat being dumped to atmosphere. I think the idea would really be to look at kind of, you know, fostering that heat in some way, shape or form into a local district heating system so that it isn't dumped to atmosphere. And like we've talked about, really looking at those 2 products or even a 3rd product, i.e. the chilled water facility. I think, to be quite honest, we now need to get our mindset around the fact that from this type of facility there can be 3 products provided, just like we provide here at Media City. You know, you can be providing electricity, you can be providing heat, and there is an opportunity to provide chilled water from these facilities. So I think really, you know, if I was saying what really could be the major addressing points, those would be the major addressing points. I guess in terms of challenges to be addressed, well, it's looking at the norm and saying, well, how do we change? Quite often in our country, unfortunately, change is difficult to accept. But, as Frank and the other guys have mentioned, we have cases over in the continent, Malmo, Denmark, etc., where these systems have been brought to fruition. They do work. There are a mixed-use community in most of those locations service, so not just commercial customers but domestics, and they are the norm. So I think, you know, we do have a lot of challenges ahead. They aren't the norm at the moment. They are very much in their infancy. But yes, I think, you know, with a lot of will, there's certainly a way.
Sorry, we have a question here in the front, Martin.
Retired engineer. I'd like to pick up on the point about this waste heat from power stations, which is just being dumped to atmosphere. You need to appreciate it's dumped at about, say, 30 Celsius. So it's not really available for district heating. If you want to get serious heat out for district heating, you have to take bled steam from the turbines, and then you can have it at more or less what temperature you want. But by taking bled steam off the turbine, you're reducing the electricity generation. So it's not, you've rather given the impression this is just waste heat that's available for free. It's not. Taking the bled steam reduces the electrical output.
It's a good point. I mean, the average power station efficiency in the UK from the raw fuel that goes in, so electricity going out, is around 35%, 40% if you're lucky. So 60% is wasted one way or another, and it is either through the cooling towers or the chimneys. But you're quite right, because they're optimised to produce electricity. The heat generation at the back end, which has been thrown away, is a low grade. So we'd have to adjust them. It's not easy to go back to our existing power stations and do that. However, we have this unique opportunity coming up. In 2016, a quarter of all the big power plants in the UK are going to be switched off in order that we comply with European legislation. And what we're supposed to be doing right now is building another 25% of our power plants to replace them. Doesn't seem to be happening, so there's a big worry there about whether we have blackouts. But when we come to build those new power plants, we should take on board what you've said and make sure that the heat distribution from the back end gives us heat at the grade we want, whether it's steam or high pressure water or even water at 90 degrees C. You know, this is all something to be decided locally. We have that unique opportunity now. I was with the Chief Executive in Lancashire County Council, and he said to me that Heysham Power Station is about to submit a planning application to replace the nuclear plant there. And I said to him, well, I hope you're saying in the planning you have to distribute the heat. If you don't do that, you don't get planning permission. So, good point, and yes, this is a unique opportunity to make that happen.
Thank you. One more point here, Martin.
Hello, my name is Kevin O'Kane. I'm an energy consultant for Verco. My main question is, if you go off and improving all your power stations and putting district heating, you might save maybe 10% on efficiency, maybe 5-10%. But there's a lot more opportunities to save energy on the demand side by improving the efficiency of houses and by looking at manufacturing practices, just the demand side of it. So wouldn't it be a lot more useful to put your money into that rather and then build a system once the demand side is quite low already, rather than improving the supply side, then reducing the demand side, and then you're going to find your systems oversized anyway at that stage?
Yeah, I would wholeheartedly agree with you. You know, just from a very simple, a single CHP installation in a building, you know, we went to one recently, and they're very, very keen to put CHP in because they see it as the technology that will deliver, and you know, it's reasonably new and reasonably sexy. But actually, what they could do with is double glazing some of the windows and putting some proper wall insulation in and insulating some pipes. So yes, we should really do the basic stuff first. Now, I think in terms of timescales, we've got time to do the simple basic stuff while the new power stations are being built and while we work out how we're going to get this heat from the new power stations and have the argument about what grade of heat's going to come off the power station. So I think they can both work together.
And I think that's absolutely right. We need to look at the demand side first and what that low-hanging fruit is. And I think we need to be careful we don't get overly distracted by spare heat or waste heat from power stations, because generally they're often a long, long way from where people live. And it costs an awful lot and it's quite complicated in moving hot, heated water long distances through pipes. And you know, generally power stations are not close to centres of populations, especially nuclear ones. And even some of the older ones that are closing down.
I'll just make one quick point. You're absolutely right, of course, and as a building service engineer, we do look to have super efficient buildings and obviously go beyond Part L, particularly with BREEAM, looking for better points. But there sometimes is a situation where you don't do that and you actually put a power plant in a building and use the waste heat. Listed buildings, for example. We did Blackburn Cathedral. We've got a CHP unit in there, about 400 kilowatts. Blackburn Cathedral, if you ever know, it's a beautiful building. You're never going to insulate it. It just loves heat. 10, 11 months a year, you heat that building. And for the first time in their history, they've got a nice, warm cathedral using heat that's waste heat. So, yeah, it's a situation you've got to look at on a basis.
Thanks. We'll move on to the second question here, and this is for Chris Marsland. What are the future opportunities to develop local CHP or community energy solutions? At what scale, and how would the associated challenges be addressed?
Thank you. I think the community scale CHP is definitely interesting, and we've had several successful installations of new homes with 100, maybe 100, 150 new homes linked to a small energy centre, and that's perfect for starting it, for getting the knowledge out there, getting the experience out there, getting the story told. I do still come back to the fact that I think that's where we should be going. We should be aiming to link these together and to link them into bigger cooperating networks, accepting the point about technologies and having the matching technologies that you can link them together. And the other part is the area I touched on earlier, and I think other people have mentioned about the lead that local authorities should and could take in this. That is the only way we're going to get the pipes in the ground to then be able to supply all these customers that will want it. We can't, we can't sort of have the customers can't just expect it. We have to provide that network, that infrastructure there first, and there are a lot of challenges for the local authorities in dealing with that. And one of the key ones, and one that Chris may want to comment on, is the availability of what's called an anchor load. It's all very well and good building a heat network and knowing you've got a town there that may want to connect, but what you really need, and it comes again back to what Frank was saying about peaky loads, you want a big consistent load there to basically pay the interest on your mortgage for that plant. You want to have a good dedicated heat customer, and you want one for 5, 10, 15, 20, that sort of level of years. And even for the waste heat from the power station, for the investment that's needed at whatever £1.5 million a kilometre to get the pipework from the power station to where the heat's used, you've got a massive investment there, and you're going to need a good anchor load customer that will sign up for a sizable period of time. And they are very, very hard to find. There has to be they are a very, very rare beast, and I don't know, Chris may want to comment on that later, because I'm sure it's a challenge he has. And one other part about it, and this comes specifically with my CHP hat on, is using the CHP to generate the heat. Great, fine, very good at doing that. But you've got to find a useful home for the electricity. And one of the issues we have, or small-scale developers for DH schemes has, is getting a home, finding a home for that electricity. Yes, it's possible to sell it in the open market, but you get a very, very poor rate of return on that at the moment due to the way the market's structured and the lack of liquidity in the market for small generators. The other option is to supply the people that you're supplying heat to, but supply them electricity. And there's various issues associated with that. There are schemes called private wire schemes, which Frank has got implemented here. But there are a lot of legal issues to do with that, and to do with, as customers, we are guaranteed effectively the ability to change our electricity supplier within 21 days if we don't like them. So that there's a lot of things that need to be considered. There's a lot of work being done at the moment on something called Licence Light, which basically means the district heating operator can become a licensed electricity supplier, which gets them over a lot of the issues without the amount of overhead that you can imagine one of the big 6 electricity suppliers needs to have. Licence Light is coming. It's being piloted by the GLA in London. There's great hope in amongst the district heating community that will come through and enable them to supply cheap electricity as well as cheap heat to their customers. But these are sort of things that need to be overcome. Possibly, maybe this is verging on some of the legislation questions that John's got set up for later. But yeah, there's just a couple of points that I think that need to be addressed to enable that sort of thing.
I mean, I concur wholeheartedly with what my colleagues just said there. I think, what would I say about associated challenges and how could they be addressed? Well, I think, like you say, we have schemes like the Media City scheme. There's a number of district heating schemes up and down the country. Chris is about to introduce one in Cardiff. We've got coal-free schemes down at Southampton, at the BBC in London. I think there are a number of parties who are basically living and breathing these schemes on a day-to-day, week-to-week basis. We've got good operational, good commercial, good contractual expertise with the forums that are taking place now throughout Great Britain, run by, like I say, the UK District Energy Association, and obviously with DEC-in feeds parties like ourselves and other parties will be feeding into those for us to make sure that good practice is actually kind of given, and that obviously what is rolled out then for these schemes Great Britain wide actually addresses the challenges that you guys and other parties, I'm sure, up and down the country are actually providing to sessions such as this. So they certainly won't be lost, they'll be captured, and then obviously we'll address them through those working groups, and hopefully you should see an implementation that does actually give you pretty much what you want across all those elements.
Thanks, Frank. We'll move on to the third question here. This is for yourself, Frank. What are the future opportunities to source heat from individual heat pumps, and how could associated challenges be addressed?
Thank you. This is really posing the answer to a question that if we are going to decarbonise the grid and we get electricity coming from whatever source, instead of having district heat schemes, we actually put other bits of kit onto our houses instead of our gas boilers to heat us. So one solution is a heat pump. And we can have, there's two types of heat pumps. There's a water-to-water heat pump, or an air source heat pump, where we take heat from the air outside the building, convert it to heat, and then either blow it in as warm air or as hot water into our radiator heating system. So the first thing to bear in mind is with heat pumps, we're not talking about the same kind of temperatures. The water side of heat pumps tends to be 50 degrees C, maybe 60 degrees C if you're lucky. The technology's been developed, and they do have heat pumps that can get us up to about 70 degrees C, but they're not as efficient. So most heat pumps are really working with a water supply around 50 to 60, which gives us a bit of a problem to existing buildings because we've sized our radiators to operate at 80 degrees C. So now we're not going to get enough heat out. So the big opportunity here is really to look at how we might apply these into new buildings. We already heard that future housing or current housing is much better insulated and much better sealed, so you don't need as much heat. So we can design those to work with these heat pumps with the lower temperatures, perhaps with underfloor heating, warm air, or radiators which can take heat at around 50 degrees C and provide enough heat to keep the house warm. That's the opportunity. There are other issues though with heat pumps. When we get down to freezing point or below, the coefficient of performance, which is a measure of its efficiency, drops to about 1. So in other words, for 1 kilowatt of electricity going in, we only get 1 kilowatt of heat. Fortunately, in our country, we don't drop below freezing that long, so it might be something we accept and we live with, knowing that when we get above that kind of temperature to 5 or 6 degrees C, that coefficient is more like 4 to 1 or 5 to 1. I think a particular issue with heat pumps that I've seen is that we don't really have the electrical supply capacity around the country to actually make that switch. So if gas runs out in 2 years' time, and apparently UK-owned gas does run out in 2 years' time, unless we can find fracking gas pretty quick or keep importing it, we're going to be a bit stuck. So my house, I have a 20 kilowatt boiler, I'm off the gas main. If I run out of gas and I switch to a heat pump, I really need, if you look on a 4 to 1 basis, I'm looking at a heat pump that wants about 5 or 6 kilowatt off the road electrically. I don't think I can get that. And if the guy next door wants it and everybody else down the road wants it, the supply mains won't carry it. So I think there's a bit of an issue there. I think the big opportunity for heat pumps really is in new housing developments where we can see them matched with a better insulation. There's a bit of a problem in hot water supply because if we can't get hot water around 60 degrees C guaranteed, we've got a real Legionella concern. So maybe we need backup with electric immersions to get the temperature to those kind of temperatures. But the opportunity really is for new developments, in my opinion. Thank you.
Thanks, Frank. Just a final question here to Chris. What are the viable alternative sources of energy or conversion techniques for homes? So looking at the different types.
I've got absolutely no idea. That's a really tough one, that one is, John. I suppose, like many, if we're looking forward to 2050, we've seen our telephones, our computers, all our technology, our cars change massively over the last 30, 40 years. We will presumably see some see the similar changes leap, quantum leaps of being able to have some sort of source of energy in our homes from our, we won't have wheelie bins anymore because it'll be consumed in our homes. We'll have our own digestion plants for all our various waste types, waste waters, waste food. But I personally, I think in the intervening period, we need to do something more on a community basis, on a centralised basis, because I think just by the very nature of that question, we are trying to push individual things out and therefore have individual properties, which will lead to all its individual efficiencies. Where I think as an energy, such a high energy consuming society, we need to be doing things on more of a communal and consistent nature together to provide efficiencies for those communities together, rather than doing things. So not only do I not know anything about it, I fundamentally disagree with the question. But anyway, I'm sure someone else in the audience may be much more equipped to talk about it than me.
I think just to back you up there, Chris, I think exactly what you're saying, that change does kick in at a pace, and obviously we've seen the rate of change in a number of our lives, facilities that support what we do on a day-to-day, week-to-week basis. I think the key on these systems is to really focus on what goes on at a local level, like Chris said, not to run too quickly, but to make sure that really we do facilitate our energy needs locally. So, like I said before, try and use the incumbent systems as top-up and standby, and as that resilience, that security going forward. But to be quite honest, to look at how we can facilitate local centralised facilities as a starter, to make sure that you've got local supply backing off local demand. And then I think, like Chris said, look at these other opportunities going forward to be more specific to buildings, to individuals, and to look at potential, like you say, new facilities in homes, in businesses, that, to be honest, then add even more locally to that centralised facility.
Just very quickly to say, I think there has been some useful work done on biogas injection into the national grid. Whether there actually is the capacity within the UK to generate enough biogas like that to make a difference, I don't know. So it's a question mark still on that technology. And regarding fuel cells, I joined the industry 15 years ago, and the fuel cell was just around the corner. It'll be with us in 2 years. And right now I'm being told the fuel cell is nearly with us. It'll be a couple of years. So I think we need to wait for the automotive industry to drive the fuel cell. Just like they're driving battery technology and things like that. I don't think, we've still got a few more years to wait for that yet.
Thanks very much. It was a tough question there, so you did well. Our fourth topic here is policy and economics, and this one's to the floor. So we've got 2 questions to start with, but by all means, if anybody has any other, we can deal with those. So what are the top 3 policy topics, and how might each be addressed? And is there a role for the IET? And what are the potential benefits to the UK economy, and how should they be represented in our cost-benefit analysis? Yep.
One of the top issues for the future is going to be one of energy storage. Frank has said that this present tri-play CHP actually relies on the grid supplies to top it up for peak lopping and that sort of thing. Now, if we extend Frank's system to progressively to other industrial complexes, then assuming there's of a similar sort of nature, they're all going to require topping up at the same sorts of time. So at the moment we haven't actually got any particularly very good methods of storing electrical energy. Some means of storage do come to mind, but they come at a considerable cost. Perhaps high thermal mass buildings to average out heat gain and loss during the day. The other possibility is perhaps storage of heat underground, because when you're building a building and you're piling safer foundations, you could also perhaps drive water pipes into the ground to have a thermal store under the building with insulation incorporated into the foundation slab. That might be a way to go to provide thermal heat storage. But again, if we think about the so-called bleed waste heat off power stations, if those power stations are load following, which has been the traditional role of at least some of the power stations, that implies that the heat bleed off has to be a variable proportion of the electricity supply that is their prime function. So there's a whole raft of really rather nasty issues. Another thing that hasn't actually been addressed in this debate is of third-party damage. Now, on this Peel site, Frank and his merry men have utter control of who digs up the roads. Nobody can go sailing in gaily. When we come to the Public Utilities Street Works Act, there's so many players who go out looking for a gas leak and create an electricity leak or a water leak and create a whatever. If somebody prangs a central heating main, hot water main, it implies that you've actually got to have redundancy in your mains. In other words, you've got to have alternative ways of switching the heat around so that you don't lose too many customers all at once. It's an immensely difficult area. In the case of Peel Holdings, where it's a relatively compact site under considerably strict control, that problem doesn't arise to anything like the same extent.
Thank you, Nick. Frank?
Frank can assist me on it. I think coming to your first point, Howard, about storage. As takes place here at Media City, you have basically kind of a number of store facilities, so buffer vessels within buildings that basically retain heat and then roll it out within the day, within the night, etc., etc. So it really is an interactive primary-secondary system. You're quite right, you know, it's always key to try and have a buffer vessel on the primary side just to keep that load that you basically kind of take from your appliances at a steady level. As you say, the off-takes on the secondary side as well, if they have storage, then that steadiness obviously continues onto the secondary side. So you're right, I mean, that is very much key to a system, and I think it falls in line with what we've said earlier about supply matching demand and having that kind of system that really is more of a baseline on a day-to-day, week-to-week basis and doesn't need topping up significantly. Obviously, that system is going to be down at some point during the year for maintenance. So yes, to rely on the incumbent systems to support is a facility that, you know, is ordinarily out there in the marketplace. I think what we've done, well, I know what we've done at Media City is we've put an extremely resilient system in place here, so that we do have 2 boilers topping up the CHP plant, and like you say, we would assume that most systems of this type would have that resilience as a given. I think in terms of, as you say, the damage to apparatus out there in the marketplace, again, that needs to be a key consideration when infrastructure is put in place to make sure that there are enough detection devices along those legs of the system, similar to what we have here at Media City, so that we can see if there's any stretch of that pipeline that is fractured or leaks at any given point in time. So again, it's as good as your system that's in place and your controls and your monitoring systems, your BMSs, that actually give you early warning signals.
Thank you, Frank. And thank you. You raised a really important issue which I've pondered on and questioned, but in this country, we get all these services and we bury them in the ground in a haphazard manner and don't really keep any record, any accurate record of where we've put them. We have here, because we did some BIM drawings, so we do have 3D drawings of what's below ground, but they are buried in mud. There's nowhere in Britain, as far as I know, that actually has proper service ducts underground. Lancaster University is a place that they do have some service ducts you can walk along. They're not great, but they do have their heat electric distribution there. I don't know anywhere else. If you take Oxford Street in London, Regent Street, they must be extremely expensive roads to dig up, but we do. We dig them up, and we hold everybody up and mess around. If you go anywhere else, and I've just come back from the ASHRAE conference in New York, they've got big street ducts under the road, carrying all the services. They've got grids, you can look down and you can see the pipes. Pretty common in Scandinavia as well. So maybe it's part of the policy. We want to start saying to government and our planners, we want properly coordinated underground ducts that we can walk around and we can see the pipes, we can fix them. We aren't going down with a big shovel hitting everything in sight. We can actually see what we've got. How you get people to change their mind and make that investment, I don't know. Because what we don't do here is we don't factor in the cost of you and me and everybody else sat in a queue waiting for those traffic lights to change because we've gone from 2 lanes to 1 lane because someone's digging something up when they actually turn up.
I think that's a really interesting point. I was this time last year. I was in Mannheim in Germany, looking at a district heating system in there, fueled by a biomass plant and by an energy from waste plant. And there was, I think it's like 18 kilometres of the district heating system in Mannheim is 4 metres above ground, and it goes down the road on pylons, and every now and then there's a drop pot, and you can see bits of steam coming off it. And it's been in place for 40 years. It's part of the infrastructure of Mannheim. Are the each pipe's probably about 300 mil, so there's 300 mil pipes, 4 meters high, running down the roads, and that's just part of what they what it is.
Was that in East Germany? It used to be.
It's in Mannheim.
Yeah.
No, Mannheim.
Yeah. Was Mannheim in Eastern Germany though?
No, Mannheim's in Western Germany.
Oh, right.
I've one question of my own here. We talked a lot about incentives and the sort of market conditions you'd need to make investments. I'm wondering what these incentives would look like. Would they look similar to refit tariffs, where you'd have guaranteed payments for the first 10, 20 years life of plant? Or would they be sort of individually bartered or negotiated between yourselves and sort of local authority? Could it be national frameworks, or what kind of way would it work?
I think the key is as the guys have said, and I've kind of mentioned over the kind of slide presentation, most of these projects are extremely long-term projects. They kind of encompass plant that, to be honest, the kind of the CHPs, the absorption chillers, the boilers of this world, 15 to 25 years. You've got basically district heating mains, chill water mains that is more like your kind of 80, 100 years life cycle. So to be honest, investments from companies tend to be over the long term, 25 years. So you want a return that fits into that kind of structure. Like I say, companies are investing significant amounts of money into millions of pounds. So a return on investment is key, and of an order that, to be quite honest, is a reasonable return on investment in the marketplace.
I think there are some different options out there for incentivisation. I think the government is looking at ways to incentivise CHP at the moment, but some of the things that come out of that is, are you looking at things like soft loans? So are you looking at enabling cheap loan rates for the capital investment in the plant, or are you looking at long-term operational support like feed-in tariffs or that sort of thing, or renewable heat incentive? So I think that to some extent the industry needs to make its mind up about what's the best model and then push for that, because there's an appetite out there for both. I think from the government's balance sheet, maybe the ongoing support might be better, but then maybe the idea is some sort of halfway house, so you'll provide support for the first 5 years, incentivising through the 5 years to cover off some of the initial build costs, some of the initial investment. That might be the best marriage between the two. One point about incentives, though, and it's something that we looked at, and we're driven by incentives. Most of a lot of these solutions are driven by incentives. I don't really want to see yet another incentive. We've got, even in the area I work in, which is quite limited, and we're the experts, we struggle with potentially up to 15 incentives for small-scale CHP. Heaven knows what a customer on their own feels like when they're confronted with this, or even not know where to look. And then if we go and add another layer on top to maybe deal with some sort of incentive for coupling that energy source into a district heating network, we talk about removing red tape and rationalising things within government. That's definitely one area they could address, the way the incentives are just layer upon layer rather than just having one or two key incentives.
And I think the huge range of incentives that are out there that are very complicated, complex, you take one, you lose another one, actually ends up delaying and making the project much more complicated in itself, because you've got even more tabs on your spreadsheet trying to work out what if scenarios at once. And what you really need to make all these things happen is load, is demand for your heat. And that is the key to it, rather than what type of incentive happens if we do this and what type of incentive we do that. Fundamentally is the amount, it is getting the right customers in place, or the right load, the right users in place, whether you're looking at a model like this where there's a multitude of customers, or whether you're just looking at a single primary load customer. It's actually someone who's going to use significant parts of that, of energy, and do it in a better way than they could do by plugging it into direct mains.
I think one other point to make about this, and we're all engineers, so we tend to think of the technology and the connection and the energy flows, but what we're asking, even with the incentives, we're asking a finance body to put money towards this. We're asking them to assess the risk on a long-term, 10, 20, 34-year basis of the risk to that money. And we need to be very clear with them. We need to have incentives that are predictable, incentives that aren't going to ebb and flow at the whim of a government. We need to have incentives that are bankable, that the finance industry can understand and can anticipate and grade in the risk. So we need to think not just as engineers, but we need to think, would a bank invest in this? Okay, so maybe the gentleman's point about banks and whether we trust them and things like that, but we still need them to invest the money, and we have to think how they think as well, because they have to understand the risk. We have to be clear and obvious on that risk, and incentives that come and go and incentives that are complicated don't help matters at all. It doesn't help persuading a finance man about technology and about long-term energy loads.
I just think one final point as well is that kind of end users need to be mindful that from centralised facilities such as this, there is an offsetting cost that kind of typically comes with this type of facility. So, end users don't need to put boiler plant within their premises. Fair enough, there needs to be plate heat exchangers, etc., etc. But there is that displacement cost again that, to be honest, could be part of a kind of a centralised fund, or a kind of a charging arrangement. Again, like Frank mentioned earlier, maintenance is borne by the centralised facility rather than the individual heat stations or users themselves. So again, there are a plethora of costs there that are displaced by such a centralised facility. To be honest, if those are kind of put into a kind of a charging structure, then the end user in effect is no worse off and could be better off by the tune of some money.
Yeah, you're quite right. I think in an overall situation, it's a more cost-effective and more reliable system from the user's point of view. So I think that would be a good way of looking at it, and it's more future-proofed in the sense that the real energy source is the supplier's problem and not the end consumer. If we run out of gas in 2 years, what do we do?
Thanks. Another question here?
In the last few years, there's been a lot of talk of smart meters and all that, and there's been a bit of use from them, but not too much. But would it be more worthwhile of kind of higher prices during peak electricity times and gas use times, and lower prices to try level out the demand on the system, and that would in turn push more towards thermal storage? Essentially, you can store during and use your storage during the high peak times rather than not using it when you don't necessarily need it.
Thanks, Kevin.
I think it's an interesting point to raise the whole issue of tariffs. I mean, I don't understand the tariffs as they are, and I'm an applications guy. I do a lot of projects for Peel and others. But at the current point in time, if you buy gas, it gets cheaper the more you use. So if you look at that, the first amount of kilowatt hours is one price, and then you suddenly start paying less. How is that an incentive for me to be energy efficient and conserve energy? So I think the whole tariff structure wants a good look at. If you start building in thermal storage and how that works as well. But at the moment, I don't understand the tariff structure clearly enough. People tell me that actually that first period has inbuilt money to pay for the the installations, the capacity. But yeah, you've got a standing charge as well. So you're already paying that. So I think the system is totally confusing. It could be doing with simplified personally. If I want a kilowatt hour of energy, how much do I pay? If we build thermal storage in as well, maybe there's an opportunity to look at a reduced amount, but we do need to keep it very simple, I think, for the consumer.
I think Frank's exactly right there. I mean, you know, part of kind of my background historically is tariffs, commercials. Tariff formulation is part of any good system. You know, kind of making sure that, you know, the actual use of that facility is in line with, obviously, you know, the best, like you say, supply matched to demand. I think the key is, as I said before, you know, this system, this facility is in its infancy. So centralised energy is in its infancy. I think at the moment, as Frank quite rightly points out, a simplified structure is probably the best way forward until we actually understand the dynamics of it. You're quite right, thermal storage is part of it. Through the UK DA forums and consultations, I'm sure that, as you quite rightly say, these matters will be fed in, and then we'll look at putting a more developed tariff structure in place to, as you say, kind of create the right behaviours in terms of usage.
I think you're right. I think smart meters, people do tend to think of smart meters and smart grids in the same sort of the same breath, as it were. But smart meters themselves, I think they can be very helpful, and I think we should strive, we should aim to have a dynamic tariff base like that. Quite how we educate people to use it, we need to think about. However, a lot of us will remember Economy 7 and white meters and storage heaters, so it's not unusual to have mixed tariffs and to be expected to operate high energy consumption equipment at specific times of day. So, you know, it's not a new concept. We're just bringing it much more dynamically into the sort of 21st, 22nd century.
Thanks. I think the time being the way it is, we need to move on here to question 5. We'll take the second of these, and it looks a bit simpler. We'll start with Frank Welsh. Assuming suitable policies and incentives are identified, what other enablers need addressing? Examples, skills and standards?
Yeah, I think this comes back to pretty much a number of points I've made earlier, that, to be quite honest, like I say, out there in the marketplace, there's a number of these facilities. So there's no need to reinvent the wheel as such. On a day-to-day, week-to-week basis, the skills, the standards, the practices, the implementation is out there. I think the key is to hone that centrally via a suitable fora like the UK DA, similar to, you know, kind of electricity, where you've got the ENA governing really the kind of the high-level policies with the network operators and suppliers through the ERA. Forums of that work very well. They make sure that throughout Great Britain, standards are actually put in place and are implemented through the various parties who are operating on a day-to-day, week-to-week basis. So I think it's a matter of looking at what bodies, what facilities, what users, what operators are out there in the marketplace, and just asking the right questions of those parties to glean that information. Obviously, forums like this assist, you know, you guys feeding in as well, you know, can only contribute to the bigger picture and, like you say, the right approach on a first-time basis, I think.
Thank you. I think what we've discussed tonight is something we see as a big opportunity for the UK. It's a different way of doing things, but the fact is we're not doing much of it. We're way behind the rest of the world. We lack the skills and the knowledge and, to some extent, the sort of willpower to get on with it. But if we can get to grips with this, it's going to be good for our economy. So our company, Low Carbon Design, is a sponsor for the Low Carbon UTC, which is being constructed in Liverpool. Now, that really came about following the Eldonian study of the district energy scheme I mentioned, and a bid to Europe for funding. So the idea of the Low Carbon UTC is an organisation, a teaching and education organisation where youngsters from Liverpool can come in and they can learn specifically about this as a business going forward. So we can see all sorts of jobs coming out of this, and how the IET might fit in is that there will be technicians, graduates, professionals coming through in this business, whether they're pipe fitting, designing, whether they're manufacturing the equipment. You know, there's a lot to do. So I think that's the big opportunity for us. There is a story from Austria. I don't know if you know, but Austria was at the end of the gas line from Russia when the story that Russia switched the gas off is true. So their country had no gas twice. and they thought, we can't be doing with this, what are we going to do? They looked around and they realised they had lots of trees and forests, but they didn't do much with. So they suddenly started looking at a biomass as a fuel, biomass as a way of making heat, producing electricity and heat, and lo and behold, they suddenly had lots of employment, lots of people training, people going out doing forestry, a whole range of good jobs happening. And you know what? They don't need the gas from Russia. They're saving themselves a fortune. So I think what we need to see is how we put these things together. And our profession, you know, us in construction, needs to see how these new jobs are going to come about. And they've got to be long-term jobs. They're not flash-in-the-pan, 5-minute jobs. We don't get these things constructed and walk away. We've got to keep them running. So we can see reliability, jobs, wealth creation, people having a better lifestyle. It fits in with sustainability.
I would say there is a skills shortage out there now, and I know the IET make a lot of statements on skills shortage and what are we going to do about it. You know, all this stuff about STEM and getting children involved in engineering at schools and make it sound something interesting that's on a par with web design and computers. Make it's not just a dirty, greasy thing that happens in some office, well, in some warehouse somewhere. So yeah, I think there is a skills shortage, and I think, you know, we are in danger of not being able to furnish this boom in district heating, which I think will come. You know, within our business, we do struggle to find good quality engineers in all disciplines. You know, it's something that has to be addressed. The other side of it, I think one thing that we tend to miss, and I know the CHPA, and I think part of one of the branches of CIBSE did a survey of what are the issues from a business perspective out there to do with CHP and district heating, and they came up with several things, a whole range of questions, sort of addressing the whole process from the very start of the conceptual design to the build, the project management, the operation, and the long-term ownership aspects of it. And they highlighted there was some issues with the engineers, the designing it weren't familiar, weren't trained. So I think that there's a need for a body somewhere out there, be it CIBSE, be it the IET, be it another body, to drive these standards, to provide maybe an accredited scheme. Maybe you get enough CPD points on a particular district heating topic, and you get a level of accreditation. Maybe there's some training schemes. So, you know, it works on two levels. It's the basic engineering skills, and then it's the specific skills that I think it's up to the industry to develop. And one of the other aspects that they came up with was there was concern in the marketplace about the maintenance. You know, it's all very well and good putting these great schemes in with all the high-tech equipment, but they have to be maintained. They can be the best schemes in the world, delivering the best heat, the cheapest heat, the lowest cost electricity, but if they don't work, if they break down, if they're not maintained properly, then there will be problems. And there is a skill shortage in that side of the market, in the operational engineering, as well as the design and build engineering. So yeah, you know, I think we've got some serious things to address, and you know, we should be able to address it. We've got the people, we just need the will.
I think the other role, the other enabler needs to happen with the professional bodies involved in this industry. The industry's got a long way to go, and there's a lot of professional and clever people involved in here. I think there needs to be a role in leadership of bringing together some of the people who control the streets, some of the people who control so it's the local authorities, it's the utility companies. There's a huge amount of experience about putting liquids down pipes in all various directions, in various formats. They need to be brought together with the people who are involved in making sure communities work together and making sure that, you know, communities are sustainable, making sure that the fuel poverty is addressed in certain communities, and by having that political buy-in along with the know-how, I think that is a role for the institutes and the professional bodies to try and pull the politics together with the engineering talent.
Just a final point on the fuel poverty. It's something when I look at these district energy schemes that jumps out at me is we as a country are very nice to people. If people need help and money, we give them it. So at this point in time, you know, we taxpayers give old people a couple of £100 a year towards their heating bill because we don't want them getting cold. So I think as we move into fuel poverty, we find people getting cold and dying, then we, the taxpayer, will bail them out. That's what we do, isn't it? So So I think now is a time to really say, well, we don't really want to spend the money that way. We don't want to just pay towards their fuel bill. We want to give them more reliable, low-cost heat, using waste heat if necessary. Now is the time to really get our act together and get the technology right and tell our policymakers and our economists that this is a better way of spending our money in the future. Fuel poverty is rising quite dramatically around the country, and I guess we, UK, British people, we don't like people seeing the mill or dying of cold. We'll want to deal with it in some way. Let's not get to that knee-jerk reaction. Let's plan ahead for it and do it properly, cost-effectively.
Well said, Jim.
Can I? Sorry, just a quick one. Hi, Mark Frith from the Irwell Valley Sustainable Communities Project. We're looking at ways of reducing fuel poverty in East Salford. In your opinion, where would be a best practice example of that in the UK to show district heating as a model?
I was going to say Media City because Peel are great landlords and they're really interested in them being long-term tenants, actually. That's what their angle is. But I guess Southampton is a good example. They put a district heating scheme in 1986 based on a borehole. It started off as a ground geothermal system, which is why if you go and visit, the water temperature is actually 76. It's quite low, but that's the water out of the ground. So all of the systems they put in, the CHPs and boilers, which back that up, and the original scheme is now only 10% of the amount of heat coming out. Everything they do supplies energy, but the heat is actually added to the distribution system at 76. If it was more than that, they'd end up putting the heat back in the ground. But when they started doing that, it served the civic centre. It was paid for by Department of Energy at a time when we had a DOE that had money. The DOE no longer exists, of course. So the initial funding was coming from government as a trial scheme. But it's grown since. It's now privately owned. But in those initial years, it served the civic centre and housing and provided heat to social housing primarily. And it seems to work quite well. It's grown arms and legs, which I think is the point Chris was making. Once you got this in, everybody wants to be on it. So the university wanted to come onto it, housing over there. There's a big John Lewis's attached to it. There's a shopping centre. And then even the Dell football ground, it got sold and converted to housing, which Barrett's built. All that's on it. So you just see these things growing arms and legs as they continue because it becomes a good thing. But I don't know. There's maybe other schemes around the country. Do you know something?
Yeah, Coventry's one to watch. They have an energy from waste plant outside the city, which for many years put hot water into the Peugeot Talbot plant. The Peugeot Talbot plant closed about 12 years ago, I believe, and therefore they installed a steam turbine to generate electricity. Anyway, as of the 5th or as of back end of last year, they reopened the scheme. They put a new pipeline from the energy from waste plant up into the city centre. The Coventry is all led by the chief executive of Coventry City Council, and all the local authority buildings are now on it. The cathedral's on it. I think there's probably so far 2 other buildings onto the network, and they're pretty confident more people are going to join. So I think Coventry is an interesting area where they had a scheme, it shut down, it's now been reopened, re-energised, put back into place, and they're pretty confident of getting that working.
Thank you.
I think I can think of 2 schemes that we've been involved with, both operated by residential social landlords. There's one in Pimlico, mostly serving high-rise blocks. And then there's another one also in London, a place called Rupel Park, which is a mixture of houses, shops, different sizes, completely different size schemes. One's 4 times bigger than the other, but all operated, as I say, through the residential social landlord, not done through councils or anything like that. And they've both been very successful. Certainly the one in Pimlico, we're looking at moving that out and linking up with the Whitehall district heating scheme. So again, going back to my point about starting small and starting to link them all together.
One final point on that is just, house heating costs of a traditional house are approaching £1,000 or exceeding £1,000 a year now because gas prices going up 10-15% a year. With modern, high efficiency homes connected to these kind of schemes, we're talking about annual heating bills of £50-60 a year. So it's dramatically less. We get it right, we really can provide people with heat very cheaply.
Right, well, unfortunately that's us out of time tonight. I'd like to thank our panel members for some really good points and great debate here this evening. And yourselves on the floor. There's almost 50 of us out there, and it's great to see such a great turnout for these Manchester events. So, safe home, and I hope you enjoyed the evening.